This video is going to be about stars and other interstellar objects. Stars are formed when gravity causes gas in a nebula to condense. So out in space, there's a bunch of loosely connected by gravity gas particles, which we call a nebula. These particles want to fall inward toward the center of mass of the gas cloud due to the gravitational pull. As the particles of gas fall toward each other, they lose gravitational potential energy and they gain kinetic energy. So remember that temperature is a measure of the average kinetic energy of our gas. So an increase in kinetic energy of these particles also increases the temperature. So I go from out here where I have a high PE, and they fall toward the center of mass of the gas cloud, increasing their kinetic energy. This means the center of the gas cloud has particles of higher kinetic energy, which are hotter and become hotter as they fall toward the center of mass. So at this point, I don't have a star yet, but I do have a star in the making. So this is what we call a protostar. And when the mass of the particles falling toward the center of our protostar is large enough, the temperature inside the core of our protostar is sufficient to fuse hydrogen nuclei to helium nuclei to create helium nuclei. We call this point ignition because the fusion reaction, which will go inside the star for billions of years, has begun. So at this point, I have an outer star and with an inner core, and the inner core of this star has now a pressure pointing outwards caused by the fusion reaction, which is the radiation pressure. And opposing the radiation pressure, I have the pull of gravity. It is the balance between these two forces in equilibrium that allows the star to maintain this state for billions of years. If I were to have two stars orbiting each other, like is shown in this picture here, I would have a binary star. Binary stars consist of two stars and rotate about a common center of mass. They're actually very common they're a very common type of star system. There are also groups of stars that have way more than two stars. These we call star clusters. So the Pleiades is one type of star cluster. It is an open star cluster. Open star clusters usually have several hundred stars. In addition to stars, they also have a large amount of gas and dust. Most open clusters are younger than 10 billion years old. The other type of stellar cluster is shown here with the example Messier 80, and this is an example of a globular cluster. Globular clusters have many more stars than an open cluster, and because they have more stars, there's very little gas and dust remaining in a globular cluster. Globular clusters are older than open clusters, so they're older than 10 billion years. Both types of stellar clusters have stars which are close enough to be affected by gravity of each other. Constellations are another type of star grouping, and they're well-known patterns made by stars, such as Libra, Scorpio, Capricorn. Stars and constellations are not close enough to be affected by each other's gravity. We talked about nebula when we talked about how stars are formed. Nebula are regions of intergalactic dust, meaning they're regions of dust found inside galaxies. It's the collapsing of the dust in these nebula that leads to the birth of stars. So we could think of nebula as where stars are born. The dust and clouds which make up nebula were formed about 380,000 years after the Big Bang. The example I have here is the Horsehead Nebula. You can see that it kind of looks like a horse. Lastly, we have our largest object we're going to talk about, which are galaxies. The example I have shown here is the Andromeda Galaxy. Galaxies have stars and gas and dust all held together by gravity, and they contain billions of stars. For example, the Milky Way, which is the galaxy in which we live, has 3 times 10 to the 11th stars, and probably even more planets orbiting those stars. Alright, that's the end of the video.